Hello friends, welcome to Engineering Funda family. In this video, I'll solve one very interesting problem based on divergence theorem. If you observe the question, here we have been given with function f and we are dealt with to identify volume integration of divergence of function f and surface integration of function f. As per divergence theorem, both of these value that should be equal. In this video, I'll solve these two calculations separately, but as and when you have been given with function and as if you want to find this or this, at the time you should prefer this, and remember both of these values will be equal only, right? But here what I'll do is I'll calculate divergence of function volume integration as well as function surface integration, right? Now I'll explain you how to identify volume integration of divergence of function. So first of all, we need to do divergence of function. So one should know what is divergence of function. See, divergence of function, that is del by del x of x component of function plus del by del y of y component of function plus del by del z of z component of function. And here x component of function, that is xy, where y is constant, partial differentiation of x, that will be 1. So this partial differentiation will be y over here, plus y component of function, that is yz, where z is constant and partial differentiation of y, that is 1. So here we will be having z, that is partial differentiation of this, plus partial differentiation of z component with respect to z with this function, that is having x constant and partial differentiation of z, that is 1. So this partial differentiation, that is x over here. Now to have volume integration, first of all you need to identify limits. If you carefully observe, here we have a, b and c. A is available over here, that is 1. B is 3 and C is 2. Now we need to identify limits as per variation in x direction, y direction and z direction. So here if you observe the limits, then that is given. See, with respect to x, limit is there from 0 to 1. So x limit, that is there from 0 to 1. Y limit, that is ranging from 0 to b, means 0 to 3. So y limit, that is there from 0 to 3. And if you observe z limit, that is ranging from 0 to c, means 0 to 2. So z limit, that is there from 0 to 2. Now we can have this volume integration of divergence of function. So here one should know volume integration of divergence of function, that we need to do after divergence of function. So volume integration, that is triple integration, and function is x plus y plus z. And here volume integration, that is having dx, dy and dz, where x is ranging from 0 to 1, x is ranging from 0 to 1, y is ranging from 0 to 3, y is ranging from 0 to 3, and z, that is ranging from 0 to 2, that is ranging from 0 to 2. Now we need to integrate this one by one. So first of all, we will be integrating this with respect to x. So here we need to integrate this with respect to x first. So here we have x. So integration will be x square by 2. Here we have y. So y into x. Here we have z. So z into x. And limit of x, that is there from 0 to 1. So 0 to 1, that I need to place. Right. Now we need to apply limits over here. So if you observe, if you apply 0 over here, then this function will become 0. So we just need to place x is equals to 1 in this. So if you place x is equals to 1 in this, then Here we will be having half. Here we will be having y. And here we will be having z. Right. Now we need to integrate this with respect to y. So if you integrate this with respect to y, then here we will be having half into y plus y square by 2 plus z into y, where limit of y, that is there from 0 to 3. Right. Now if you apply y is equals to 0, then this function will become 0. So we just need to place y is equals to 3 in this. So if you place y is equals to 3 in this, then 3 by 2, that will be there. Y square by 2 means 9 by 2. So 3 by 2 plus 9 by 2, that is 12 by 2, means it will be 6. So this much term, that is 6, plus z into y is there. So z into 3 means 3z. Right. Now simply we need to integrate this with respect to z. So here 6z plus 3z square by 2 is there, where limit is there from 0 to 2. Right. Now we just need to place z is equals to 2 over here. So if you place z is equals to 2, 6 into 2, that is 12, and 3 into 4 by 2, so that is 6. So 12 plus 6, that is 18. So 18, that is what the total calculation. So this much calculation, that is resulting into 18. Now I'll calculate surface integration of function, and you will be getting that is 18. But that calculation is a bit tedious. Here we have in total 6 surfaces. So separately we need to calculate this for all 6 surfaces. Let me explain you how to do that. So here first of all what I'll do is I'll identify surface integration for this surface first. So let us consider this is surface 1. Right. Now with this surface, if you carefully observe, here x is constant. Right. Here x is constant. Let me note it down. Here x is constant, and that is a, that is 1. So x is 1 over here. Now if you observe with this surface, then here y is ranging from 0 to 3. Right. Y is ranging from 0 to 3. So y belongs to 0 to 3. And if you observe z, then that is ranging from 0 to 2. So z belongs to 0 to 2 over here. Right. Now we need to understand what is this surface. So here we need to understand, see direction wise, what is this surface. So this surface, that is having variation in y and z only. So that is dy dz surface. And here if you observe the direction of this surface, then always remember direction of surface, that will be perpendicular to surface. So with this surface perpendicular to this, that will be in this direction, means it is there in x direction. X direction means it is there in direction of I. Right. Now I'll be explaining you calculation of surface integration of this function for this surface 1. So here we are deal with to identify this surface integration for surface 1 for function. Right. So here first of all you need to understand one thing, surface integration is double integration, and f dot s that we need to do. So I direction component is present, these components are not there with surface, means dot multiplication of f dot ds, that is resulting into xy only. Right. Here we will be having xy only, and we need to integrate this, where y is ranging from 0 to 3, z is ranging from 0 to 2. Now this integration is quite simple. See here x is 1, so I am writing x over here, and y integration, that is y square by 2, where y is ranging from 0 to 3 and z is ranging from 0 to 2, and one integration is z, which is ranging from 0 to 2. Right. Now x is equals to 1, y is equals to 3, that you need to place, and z is equals to 2. So if you apply 1 into 9 by 2 into 2, so that is resulting into in total 9. Right. So surface integration of function with surface 1, that is 9 only. Right. Now I'll explain you calculation for second surface. So here I'll be considering second surface, that is this surface you see. So with this second surface, we will be having calculation for surface integration. So with this second surface, if you observe x, so that is 0, right? So here let me note down that for second surface, x is equals to 0. Here with this surface, y is ranging from 0 to 3. So y belongs to 0 to 3 and z belongs to 0 to 2. Z belongs to 0 to 2, right? Again, if you observe that surface, that is ds, right? So here ds is as per variation in y and z. So that is dy dz, and direction will be perpendicular to this surface. So perpendicular to this surface, that is there in direction of x, means it is having only I component, right? Now again, we will be applying same principle. What we will be doing? We will be calculating surface integration for this second surface. So here we will be calculating f dot ds. Now if you carefully observe, see that calculation will be happening as per this only. Here f dot ds that we will be doing, right? So only I component is there. So f dot ds, that will be xy into dy dz, right? Where x is ranging as per 0 value. So if you apply x is equals to 0, this function will become 0. So you don't need to calculate this integration, right? Now I'll explain you few more surfaces. In total 6 surfaces are there, right? We have calculated for these 2 surfaces. Now I'll calculate this for these 2 surfaces. First of all, I'll consider this surface. Let us consider this is surface number 3. With this surface number 3, if you carefully observe, y is equals to b, that is 3. So let me note it down. Here y is equals to 3. And if you observe this surface, then x is ranging from 0 to 1, right? And if you observe range of z, so that is there from 0 to 2. So z belongs to 0 to 2. Now you need to understand what is this surface. So this surface, that is ranging as per x and z, right? So here see ds, that is having direction, that is having variation as per dx and dz, and that is having perpendicular direction to this surface. So perpendicular to this is there in y direction. Y direction means it is there in j direction, right? It is there in j direction. Now we need to solve surface integration. So here we will be solving this for third surface, right? So now we need to identify f dot ds. So surface integration, that is double integration f dot ds. So here we have j component. We don't have I and k component. So dot multiplication over here, that is yz into dx dz, where x is ranging from 0 to 1 and z is ranging from 0 to 2. Now here if you observe y, that is 3. So y is 3, z integration, that is z square by 2, where limit is there from 0 to 2, and x integration, that is x only, where limit is there from 0 to 1. So if you place this 3 into 2 into 1 means it is 6, right? Now same thing that we will be repeating it for this surface. So here now I'll consider this surface. Let us consider that surface is surface number 4. Now for fourth surface, if you carefully observe y, so that is constant and that is 0, right? And here x is ranging from 0 to 1 and z is ranging from 0 to 2, right? Now with this, if you carefully observe surface, so ds, so that surface is ranging with respect to x and z. So we have dx dz and it is perpendicular to, it is having direction perpendicular to this surface. So that is there in the direction of y, means it is having j component only, right? Now we will be applying surface integration for fourth surface, right? For fourth surface. So if you do that, then here we will be having double integration, and here see dot multiplication with respect to j, that is having only yz. So here I need to write yz dx dz, and if you place y is equals to 0, you don't need to calculate this even, it will be 0 only, right? Now same thing that we will repeat it for two another surfaces. So we have solved this two surface and this two surface. So now I need to calculate these two surfaces. See, first I'll be calculating this surface. Let us say this surface is surface number 5. So for surface number 5, if you carefully observe z, so that is constant, that is c, and that is 2. So I'm writing 2. Here x and y, that is varying. So if you observe x, that is varying from 0 to 1. And if you observe y, that is varying from 0 to 3, right? So that is how you need to identify how variation is there. Now you need to understand what is this surface. So here surface is varying with respect to x and y. So dx dy is there, and direction of surface will be perpendicular to this surface, that is there in this direction, means it is there in z direction. So it is having only k component, right? Now we need to have integration. So this is what we will be doing it for fifth surface, right? We will be doing it for fifth surface. Surface integration is double integration, and ds dot f that we need to do, where only k component is there, means this dot multiplication, that is zx, right? That is zx, and here variation is there with respect to x and y. So dx dy, where x is ranging from 0 to 1 and y is ranging from 0 to 3. Now we need to place all the values. See, z is 2. So here I'm writing 2 into x integration, that is x square by 2, where limit is there from 0 to 1 and there is nothing with y. So integration is y, where limit is there from 0 to 3. If you solve this, see 2 into half, 2 into half into 3. So 2 is getting cancelled. So this will be 3 only, right? Now I'll explain you same calculation for this surface. So that is last surface, which is surface number 6. Now with this surface, if you observe carefully, that z is constant, that is 0. That z is constant, that is 0. Here x is varying as per 0 to 1 and y is varying as per 0 to 3. And now we need to understand how surface is there. So surface is having range as per x and y. So dx dy, and it is perpendicular to this. So it is having the direction which is there in the z direction, means it is having k element only, right? Now we need to simply integrate this. So surface integration for sixth surface that we need to do for this function. And See here we have k element. So k element that is having only zx. So we need to place now double integration where this f dot ds, that is zx only, where range is there with x and y. So dx dy is there. If you place z is equals to 0, if you place it, then you don't need to calculate this even, it will become 0 only, right? So this is how it is bit tedious to have a calculation of surface integration 6 times. So if you observe, see we have 0, 3, then 0, then 6 over here, and then we have 0 and 9. So 9 plus 6 plus 3. So in total, how much surface integration is there? That is 9 plus 6 plus 3 and zeros that we don't need to add even. So this will be 18 only, right? So you see, we have calculated earlier by that volume integration of divergence of function. So that is 18. So 18 that is getting matched over here. But you need to compare both of this calculation, and now you need to decide which calculation that we should be doing. But obviously we should be doing that by divergence of function volume integration. That will take bit less time. I hope you have enjoyed this, but you need to follow the process, right? Once you understand the process, calculation will become easy. I hope you have enjoyed this. Still, if anything that you'd like to share, just note it down in comment section. I'll be happy to help you. Thank you so much for watching this video.